Hi everyone, I'm Karan Khanna from Team 9 and I welcome you to our amazing Breaking Bricks game. As promised in Sprint 1, we are here again with a full version of game. So let's see the demo of our game. So this is the start screen of our game. Here we have two options such as play and instructions. So when we click hit and then instructions, so we can see the navigation options here, and this is the level 1 screen. Here we have implemented timer functionality as well as score updation, and the level 2 is different UI for our game. So we have a paddle and a ball. So the objective of the game is very clear. User has to break these bricks using the ball and control the movement of paddle using the keyboards. So this is the level 1, and also you can see these blue bricks, they are bonus bricks. They can emit multiple ball which can help user in finishing the game early and moving to the next level. So this is the level 2 UI of our game, which is different than the level 1, and here we have different pattern of the bricks, and as you can see, on clearing the level 1 only we can get here. So here you can see I'm playing in the level 2, and we can go into level 2 after completing our level 1s successfully, and this is a quite challenging level. And here also we have different bonus breaks, and the design pattern has implemented a different UI for this level. So the arrangement of bricks is different in this level as compared to level 1. So let's discuss now our activity diagram for the team. So here you can see we have player and various components such as level 1 paddle, ball and bricks. So if user clicks to play, then behind the scene all the components of a system gets created, and the level UI is being served to players to play. And when the player releases the ball from the pedal, the ball can go to collide with edges, bricks, or it can fall below the level. If it falls below the level, then we have the game over sequence here, or else we can have brick disappearance, score updation, or it can be triggered to level 2. So now let me take you to our use case diagram, where we have play, game, move paddle, view score use cases, and they further include display paddle, collide, collisions, such things. And this is our class diagram, where various patterns are being implemented, such as a state pattern to control the state change, a command pattern to map the keypad movement of the pedal, and observer pattern. Now let me show you our team's Kanban board. Here you can see we have covered successfully our 15 story points, 3 story points per member, and it includes few use cases such as pedal movement and mix core updation. You can see the in process bar to be empty for each member. Now let me take you to our cycle time. Here is our cycle time for our project. So we have started on 4:05 and then we ended shortly. So now let's hear from our teammates more about their contribution.
Hi, this is Kavya. My task for Sprint 2 are handling design brick patterns for different levels, that is level 1 and level 2, implementing random bonus bricks in the brick pattern, that is pedal long, pedal short, multiple balls, implementing template design patterns in the game, GIF image implementation for GIF images, and also design class diagrams. Here you can see the slides for the template design pattern implementation. My participants are abstract class and concrete class. Screen design is the abstract class, and level 1 and level 2 are the concrete classes. Screen design implements the pedal, ball, image, score, timer implementation. Screen design consists of an abstract class, that is a brick pattern, which is implemented in level 1 and level 2. Level 1 and level 2 has different algorithm for this brick pattern arrangement. Next, what you see is the class diagram. Here you see the screen design, which is the abstract class. Level 1 and level 2 are the subclasses of this, that is the concrete classes. Here the brick pattern arrangement is the abstract class which is implemented in level 1 and level 2. Level 1 has different algorithm for brick pattern arrangement and level 2 has different algorithm for brick pattern arrangement. Next you see the demo of implementation of this template pattern. Initially this is the level 1 screen. Level 1 screen has the brick pattern arrangement. Here blue bricks shows the random brick bonus brick arrangement. All these are blue bricks are the bonus bricks. There is a level board and also there are GIF images at the corners. There is a pedal and the fireball with the scoreboard and the time board. As you can see we are playing the game and I'll show you the level navigation from level 1 to level 2. So yeah, this is the level navigation. I have moved from level 1 to level 2. This is my level 2 screen. Here the brick pattern arrangement, you can see there is a different brick pattern arrangement, and the blue bricks are the bonus bricks. They have multiple balls, long pedal, short pedal, and it also has GIF images at the corners, and other corners has the score and time board. Level 2 board also present at the top center. Thank you.
Hi everyone, it's Karan here again, and let's now discuss my task. So I implemented command pattern for the pedal movement. I handled collision of ball object with other objects, and also I designed class diagram and use case diagram for the functionality. So whenever a user wanted to move right or left its pedal, so this was being handled by the command pattern. Also, whenever a user presses the space key, the ball was emitted out of the pedal. This was also handled by the command pattern. Here we use pedal as a client and receiver, and motion invoker as the invoker class, with iMotion command serving as command interface and its implementation being motion command class. So let me show you the class diagram here. So the pedal class act method has Greenfoot is key API, which was checking for right or left keyboard key pressing, and after that we would call invokers invoke method, which would again delegate the call to motion commands execute and further to receiver dot do action. Now pedal class also had the receiver inner class, which would cater to this request and move the pedal right or left or emit the ball out of pedal. So now let me show you a little demo. I'll just compile the class. So you can see here we can move our pedal right or left using the command pattern, and also press the space key to move the ball out of the pedal. Now this fireball is colliding with the edge and coming back. So this was also handled by me. So as you can see, if it hits with brick, its reactions are random. That was done using Greenfoot random function, and similarly with the edges and other objects. This was my part. I hope you liked it. Now let's hear from my other teammates.
Hello friends, my name is Komal Deria. My task is to emit multiple balls in the world from brick when ball collides with it, making pedal long or pedal short when a ball collides with a particular brick, making brick disappear from the world after the ball collides with brick, then creating bricks with multiple colors, that is red brick and golden brick. I have implemented factory method design pattern to implement my task in the game. Following are the participants of factory method. We have iBrick operation, which is a product. It defines interface of object that factory method creates. Then we have multi-ball, which is a concrete product. It implements iBrick operation, and its task is to emit multiple balls in the world. Similarly, we have pedal short and pedal long concrete products, which causes pedal to become short and long respectively. We have a special class called as no operation. So we require sometimes the brick should disappear from the world without performing any operation. For this we require a special class. Then we have iBrick, which is a creator interface. Then we have brick creator, which is an abstract class. It declares a factory method and returns an object of type iBrick operation. Then we have multi-ball brick, which is a concrete creator. It overrides the factory method to return an instance of multi-ball, and which would finally emit multiple balls in the world. Similarly, we have pedal long brick and pedal short brick, which would return an instance of pedal long and pedal short class respectively to perform their task. Then we have red brick and golden brick, which overrides the factory method to return an instance of no operation class, so that when the ball collides with such brick, it just disappears from the world. This is my class diagram. Here we have the product and concrete products, then we have the creator and concrete creators. Let's see the demo. Here you can see when the ball hit a particular brick, then multiple balls are emitted in the world. Here you can see when the ball hit another particular brick, the length of the pedal increased. Similarly, when the ball would hit another particular brick, the length of pedal would decrease. So this all has been implemented using factory method. That's it from my side. Thank you.
Hi everyone, I'm Dinesh. My tasks are calculating the score and to display the updated score dynamically and adding the background sound. Let us see the implementation. The process is to increment the score and removing the brick object that is touched by the ball, and the observer pattern makes the implementation easier. We can see that eye collision subject and eye collision observer provides the required operations and has to be implemented by the concrete subject, which is the ball, and the concrete observers, which are score on the brick observer respectively. Initially, the score and brick observer instances are attached to the concrete subject ball. When the ball comes in contact with the brick, it calls the update method in score that increments the score value and updates it in the display. And the update brick observer will remove the corresponding brick from the world. Let us check the demo. The game is started. Here you can see that when the ball hits the bricks are removed from the world, the score is updated dynamically, and finally, the score is displayed with the game over screen. Thank you. Let's move on to the next person.
Hello everyone, I'm Vinisha from Team 9. My task for Sprint 2 are handling game over for various scenarios, implementing timer for the game, implementing state design pattern in the game, and designing class diagram. This is the state pattern implementation for maintaining different states in the game. Game manager class is the context. Game state class is the interface of the state diagram, state class. G state class is the state, and game level 1, game level 2, game over are the three concrete state subclasses. This is the class diagram which I have implemented for state pattern in the game. Game manager maintains an instance of a concrete state subclass that defines the current state. Game state is an interface for encapsulating the behavior associated with a particular state of the context. GState is the class which implements the game state interface. Game level 1, game level 2, and game over are the three states for the whole game. Game starts in game level 1 state and it navigates to game level 2 or game over state once it meets the required criteria. Now let's have a small demonstration on what I have implemented in this game. Here, though the time is left out with 3 seconds, game over is displayed because the ball goes down the height of the paddle. Now let's test with another scenario of time becoming 0. The game started at 10 seconds and it is counting towards 0. Once the time becomes 0, the game over board is displayed. That's all from my part. Thank you.